afternoon, ladies and gentlemen. It's my absolute pleasure to welcome you all to today's webinar. Sisecam presents Parametric Architecture, a revolutionary design tool. It's heartwarming to see such a fabulous response to this webinar series brought to you by Architect and Interiors India. Thank you for taking time out and being here today. My name is Indrajit Sauji. I head the construction and design vertical for ITP in India, and I'll be your host today. Before beginning the webinar, I would like to know if the audio and video are clear. If at all you have any issues with the communication, please do let us know by the chat so that we can sort it out soon. Let me give you a brief introduction about ITP. ITP Media Group is one of the largest foreign media companies in India. The group now publishes more than 100 weekly and monthly magazines and has a wide portfolio of market-leading digital properties. Some of our well-known global titles include magazines like Harper's Bazaar, Vogue, Time Out, Cosmopolitan, Grazia, Construction Week, Architect and Interiors India, and more such prominent titles across industry verticals. In India, we have 7 titles, including Architect and Interiors India. Architect and Interiors India is our flagship title and is amongst the most respected and widely read B2B titles in its domain. Let me come back to the webinar topic, Parametric Architecture, a revolutionary design tool. Parametric design is not unfamiliar to territory for architects. From ancient pyramids to contemporary institutions, buildings have been designed and constructed in relationship to a variety of changing forces, including climate, technology, use, character, settings, culture, and mood. The computer did not invent parametric design, nor did it define architecture or the profession. It did provide a valuable tool that has since enabled architects to design and construct innovative buildings with more exacting qualitative and quantitative conditions. This episode of the webinar series brings together leading experts in the field who will share their unique perspective on parametric architecture and how it revolutionized the field of design and architecture. We are looking forward to an interactive and engaging session and need your complete involvement. And we'll take few live questions during the session. We'll be running a Q&A at the end of the webinar also. So we have enabled our Ask a Question feature. It is on the control panel at the bottom of your screen. So if you have any question, just type in there. For those who want to ask a live question, you may do so by clicking the hand icon in the control panel and my team will get in touch with you. I promise we'll try to answer as many questions as possible. And if you miss anything, don't worry. We'll be sending around the on-demand recording to your mailbox and it will soon be available on our website as well. Without any further delay, let me introduce our partner for today's session, Sisecam Flat Glass. Sisecam Flat Glass is a global player of the glass industry and has a production facility spanning across 10 countries, namely Turkey, Bulgaria, Romania, Germany, Slovakia, Hungary, Russia, Italy, Egypt, and India. Sisecam operates in 4 main product categories consisting of architectural, automotive, solar energy glass, and glass for home appliances. Sisecam Flat Glass aims at meeting all customer expectations in its target market with its high quality product, state-of-the-art technology, and its efforts focused on saving energy for environmental protection. Thank you, Sisecam, for partnering with us and helping us run this informative series of webinars. Now, let me introduce our esteemed panel for today, starting with Amit Gupta, founding partner, Studio Symbiosis, Germany. Melike Altinisik, founder and design principal, Melike Altinisik Architects, Istanbul. Mr. Sushant Verma, founding partner and design head, Rec Labs, Delhi, India. James Law, CEO and founder, Cybertecture Architects, Hong Kong. Esra Aydinoglu, architect and architectural glass product manager, Sisecam Flat Glass, Istanbul. And I am joined by my colleague, Mr. Bibhor Srivastava, Group Publishing Director, ITP Media, India, and he'll be moderating today's session, and Mitali Kurdekar, Editor, Architect and Interiors, India. Now, before I hand it over to the moderator, I have an interesting video for you all. Rohan, can we have the video, please? Looking at this interesting video, I have a question for Esra. It's like, if you guys allow me, like, I have a quick question for Esra. How do the right building materials affect human health and well-being? How would you describe it through glass?
Thank you, Indrajit. If you let me, I'd like to share my screen before answering your question. Yeah. Glass is a miraculous material with its extraordinary properties. It's transparent, prevents entrance and infiltration of water into our living environment. You can look through it and establish a connection with the nature without being subject to the outdoor climate or weather. It is phenomenally strong and even can be used as a structural component in buildings, provides quality to our lives. It may act as an acoustic barrier and maintains thermal comfort. Natural daylight plays an important role in the comfort, health, and mood of the human beings. Before COVID-19, we were spending over 90% of our lives within buildings. After that, unfortunately, we're spending much more time in our offices or houses. Glass means feeling natural daylight in inner space with energy efficiency, safety, security, and noise control. Our quality of life strongly depends on daylight. Because humans actually programmed to live outside, daylight plays a fundamental role in the body clock. Numerous research studies have demonstrated that glazing has profound implications in terms of human health, happiness, and productivity. For example, in healthcare, research findings demonstrate that access to daylight provides a reduction in the average length of hospital stay, quicker post-operative recovery, reduced requirements for pain relief, quicker recovery from depressive illness, and disinfected qualities. There's also a growing body of evidence that daylight plays a critically important role in the prevention and treatment of obesity, heart disease, and other illnesses exacerbated by stress. In educational buildings, access to daylight has been shown to result in a dramatic improvement in students' academic achievement, behavior, calmness, and focus. Lisa Heshong, who is an internationally recognized expert on the effects of light on learning, has undertaken and reviewed studies on thousands of students examining the effects of spatial qualities such as classroom size, orientation, daylight on learning performance. Heshong's conclusion is that daylight is a drug that stimulates the production of serotonin, dopamine, and gamma-aminobutyric acids in the human body, enhancing muscle coordination, calmness, and focus. In the workplaces, numerous studies have identified that employees prefer to work near windows, which fully utilize natural light rather than artificial light. Over 1/3 of employees feel that they don't get enough natural light in their workspace. 47% of employees admit they feel tired or very tired from the absence of natural light or a window at their office, and 43% report feeling gloomy because of the lack of light. These findings support a larger trend of the growing importance of employee well-being. In buildings of all types, including the residential sector, many of the studied benefits associated with daylight and connections to the outside world can be equally realized, thus contributing to sensations of well-being. Glass integrates inner space with nature. In other words, connects inner and outer space. The human eye can distinguish about 10 million colors, and as Sisecam Flat Glass, we believe that even 1 in 10 million shouldn't be missed. Our group, Sisecam, with 85 years of experience, operates in 4 different areas in glass business. We have 43 plants in 14 countries with 22,000 employees. We are very proud to be the only global company operating in every field of glass. We have 19 plants in 10 countries, from Egypt to Russia and from Italy to India, serving to construction, automotive, energy, and household appliance industries. This is our headquarters in Istanbul. We call it Heart of Glass. The project's design is the result of a collaboration between the world-famous architectural group SOM and Turkish firm Design Group. We have an experience center in our headquarters, which invites us into an impressive journey and exploration towards the nature of glass itself. This miracles material is able to go beyond being the material which only takes the daylight into the place. Now it is meeting the different needs with its different features, for example, providing effective energy saving, safety and security, and also noise control. We are offering glass consultancy to decision makers for the selection of right glass according to these requirements. We handle the projects from design stage until the building's opening stage. We have reference projects all over the world. I would like to show you some of our landmark projects. Of course, in this limited time, I can only show you a few examples. For more, you can either check our reference projects catalog or mobile application glass projects. Istanbul TV Radio Tower is one of our reference projects. Luckily, we will have the chance to listen to this iconic project from Mrs. Melike Altinisik in this panel. We are very proud to be a part of this iconic project. As you know, building information modeling is the key tool for parametric architecture. It presents all the objects in a building along with their physical, technical, and commercial characteristics. The technology makes it possible to quickly assess shipping and construction timing, life cycle cost, and other key variables, besides making design stage more easy. As one of the largest glass manufacturers in the world, we are working to spread this technology even more. You will soon find all our products as smart objects and materials in BIM libraries. In Sisecam Flat Glass, we have solutions for all needs of the projects and unlimited creativity of architects. So please do not hesitate to ask any question to us either in Q&A and or through our email account. Thank you.
Thank you, Esra. Thank you. This was wonderful as always. There's like so much information and really relevant. We have an important announcement to make. May I pass it on to Matali to do the honors?
Thank you, Indrajit. Thank you, Esra, for that really wonderful presentation. It's really set the tone for what's to follow. We're looking forward to a very interesting discussion. But before that, I just want to take a minute to quickly sort of introduce you to something that we're doing at Architect Interiors this year. This is a very exciting new project that we've announced just a short while ago, and I thought this is the perfect opportunity to talk about it. So as most of you are aware, for the past 9 years, we've been having the iGen, and it's got a fabulous response. Every year, we get to introduce 50 emerging, up-and-coming, budding architects and interior designers. And this year, we're taking it one notch further. We want to bring the people in. We don't want to be the only ones to, have a say. So we're introducing a People's Choice Award for the iGens that we've chosen this year. And to tell you a little more about it, we've got a short video that we'd like to play. And we want to sort of invite votes and get as much audience participation as we can. So Rohan, if we can have the video, please. Thanks, Rohan. We've already got a wonderful response, but we want to invite as many of you to encourage our young, up-and-coming, emerging architects and interior designers, and choose your favorite as the IGN People's Choice Award winner. So I think with that, I'd like to pass it on to Bibhor so we can, really talk about what we're here for, which is parametric architecture.
Well. Thank you, ladies and gentlemen, and our wonderful viewers. Thank you. We can see the numbers coming up fast and strong. That makes my job much more exciting. And what to say, Esra, big thank you to you and ladies and gentlemen who've been attending and seeing the webinar. We have never had such a wonderful partner who really come forward and co-created many meaningful platforms. We have already done with her, and today is one of the most interesting topics. We are talking about parametric architecture, and I have to be very honest with you that it's something not too very conducive and familiar with. That's why I got this excellent panel here. Well, I'm just going to talk about this. The brilliant Zaha Hadid once said, I really believe in the idea of the future. Given that she was one of the greatest champions of parametric, and what an parametric architecture may be a relatively new concept in the Indian context. It offers numerous possibilities. We have already witnessed this with some iconic structures that have been created the world over using this futuristic technique. And this is only the beginning. To bring us to speed and throw some light on what parametric architecture truly entails and what it will become going forward, we have this illustrious panel with me, ladies and gentlemen, this evening, who are going to really talk about their projects and real meaning. And let me just very quickly bring my friend James Law, all the way from Hong Kong. And for the reason to bring him up, because he's really hard pressed for time, but we don't want to let him go without sharing. So James, more than the definition of parametric architecture, for the viewers here, and especially in India, in this part of geography, how simply can you tell us about what does it mean to you, and how have you been able to imbibe in your projects? James.
Thank you very much for inviting me. This topic is immense. It's opened up the whole new potential behind architecture. I think architecture, before the technology was able to tap into the parametrism. So maybe I just use my some of my projects to illustrate the point. Okay, so the work that we do, we also classify it as a parametric architecture. The reason is that because we believe that architecture is actually a technology. It's a technology that can shape and solve problems for people and cities. And so the way in which architecture can tap into parametric intelligence is very important. We use parametric less for form making, but we really use it as a way to make our architecture functional. The first project I want to show you is we're actually working on a moving architecture. We are working on the Hyperloop with SpaceX. And it's literally a building that floats in a magnetic field. In fact, it is very parametric because the architecture can only survive in a parametrically organized environment of how to use the technology to control the flow of the magnetic field, control the safety of the moving carriages, etc. And this kind of dynamic architecture was never possible until the technology was available for us to be able to calculate at that speed. Architecture has become more dynamic, and architecture has gone beyond buildings because of the capability to be parametric. Other interpretations of parametric that we have actually done in our projects is, for example, the interpretation that a building is more than just a building structure. It is a living mechanism that people live in. So here in this building in Dubai, we've interpreted an entire building almost like a giant iPod, where the parametric capabilities of the building, which includes monitoring and sensing the way in which people live in the building, actually informs the space. It controls the energy, controls the water, controls the temperature, controls the content within the building. So the architecture's lifeblood is the parametric data that is garnered from the life within the building itself. And then the devices within the buildings. We've been developing a series of devices that taps into the parametric characters of the people living inside the building. Here, this is an example of an intelligent mirror that monitors the state of your health, and therefore that data parametrically informs the space, filters the air, delivers the right temperature of water, reminds you to exercise, etc., all because of the capability of parametric architecture. And then on a larger scale, we've been designing almost like mega structure cities. So this is a project in Abu Dhabi. It is a city for 45,000 people to live and work in. And this building actually runs a kind of pseudo nature that is driven by the parametric architecture. So how we grow plants and agriculture within the building, how do we circulate the air, how do we monitor the way people move around the building, is all using sensors and very sophisticated algorithms to make this kind of mini planet actually possible. And to get the data to inform architecture is also a kind of parametric architecture. So we design and build things like this, which is kind of intelligent totem poles that we can plant around the city. Here are two examples we've done in Hong Kong, which actually monitors the environment, counts the traffic, counts the people flow, sees the patterns of the use of the space around. And this data is then shared with the regional architecture, the neighboring architecture around, so that the buildings around can, really respond to the needs of the people out in the public space. Last but not least, recently we've been doing a project which parametrically links the performance of these concrete water pipes into becoming domiciles for homeless people. What we do is we look at each site situation, whether they need to be stacked up or not. The computer actually calculates the optimum weight, the thickness of the concrete, and then informs the factory to produce them at the right optimum and maximum efficiency or weight to performance ratio. So again, this has got a lot of kind of parametric calculations behind it in order to make it actually feasible and efficient for a kind of modern architecture. That's the kind of work we do. And we really kind of think that parametric architecture isn't just about form making. It's not just about, although that's part of it, creating interesting forms, really intelligent forms, but there's a kind of parametric life behind the architecture that really affects the people living inside the architecture in a way that is much, much more intelligent and more empowering than in the 20th century. And this is, I think, the really exciting part about parametric architecture for us.
James, very interesting, and I think you really brought technology and lives of people together. What gave you this idea? Because I remember the one that you mentioned about the glass talking and giving you. This has been done many years back, in your work. What propelled you to go in this direction?
Well, I think very early on, I remember thinking that everything that we're making today, whether it's architecture or a device, is all about hardware and software. And in that interaction between hardware and software is the intelligence behind something. And I think parametric architecture is the first incarnation of how architecture can actually be intelligent, because it is no more just an assumed kind of form or shape or function, but it is something that could respond using other technologies and other intelligence coded into it. And so just like a smartphone really has that kind of characteristic of the hardware and software relationship, I really think that architecture in the 21st and 22nd century is all about that interaction between software and hardware. And that's what drives our work. It's really an exciting field that architects can go beyond architecture. It's almost like architects can also become, coders, and architectures can also become inventors and application developers, because that's essentially the lifeblood of a new kind of architecture.
No, very well. And I think that's very encouraging, beyond your scope and embracing new formats, new technologies. And let me very quickly get Melike. Melike, can you please unmute your mic, please? I think, the viewers are simply loving it, and I can see that as well. And I think we got one perspective from our friend James from Hong Kong. And let's listen what's happening in the other part of the, the globe, which is Istanbul. Melike, all yours.
Thank you very much. First of all, I would like to also share my screen. It's very important topic today for me because parametric architecture is actually, in my opinion, it's a smart computational design technique. It helps us to generate the dialogue in between architecture and technology. It enables us to create all the grays in between black and white. There is no 0 and 1. There is all kind of opportunities which we can design and create with this parametric architecture. Advanced technologies implementations defines today the way we think and design in the last decades. We need to live in smart cities, and designing the smart cities requires smart design and smart construction methodologies. Most of the time, we take already existing computational design and fabrication techniques from other industries, such as aircraft design or car in this industry. By misusing all those technologies, we apply those systems into architecture in our studios. CNC, laser cutting, 3D printing, robotic fabrications are just some examples of those tools which we are using in our daily life. Once you discover these unseen logics behind these systems, then you can start working on multidisciplinary platforms. Each project has its own challenging problems and they require unique smart solutions. In my studio, actually related to the subject, our design approach also aims to apply those computational design systems into architecture. And we work on varying scales of projects. Today I will show you Istanbul futuristic 369-meter tall TV tower in Turkey, and another project, world's first pioneer sailed robot science museum located in South Korea. Both of them are using very unique computational and parametric design tools from design to construction. The first one is Istanbul TV and Radio Tower project. It's located on the Asian side of Istanbul. It is 369-meter tall TV and radio tower project. It's a telecommunication tower, but it has public functions also inside. So to be able to shape this building, we used all the wind data located around this area. And we give the shape of the tower using all these data. So that's why the facade looking towards the Asian side of Istanbul is different than the facade looking towards the European side of Istanbul. And all these parametric tools actually enabled us to create really important dialogue between parametric design and also smart construction on site. We use totally advanced engineering techniques. So we build up the building from bottom-up approach. So we built 4 or 5 level high blocks on the ground and we lifted them up 200 meters above the, around the core of the building. So there are more than 2,500 different facade panels. Each are curved and they are using the glass reinforced concrete, and this already requires a specific kind of digital fabrication, and also mock-up makings were very important for this tower. So here you see that we hope to use these drones for the facade maintenance in the near future for this tower. Since we have been using all these parametric tools, they will enable us also for the, after the opening of the tower, give us this advantage for the maintenance. And very soon, hopefully next month, all the public will be able to come and watch the panorama of Istanbul, almost 400 meters above sea level. We hope to see you also here in Istanbul after this COVID-19 days. And the next project I would like to shortly mention is this Robot Science Museum project. It's located in South Korea. For such a smart city, we wanted to really propose a smart design and construction methodology. So this building also will start its first exhibition with its own construction. And here one of the most important subjects is this. Currently, in our era, we are using all these computational design tools. They are communicating with the offsite manufacturing. But the most important subjects for the near future will be doing this on-site. And to be able to do this, we have to really create very smart design tools to be able to control every single element during the design process, to be able to communicate on site with the building builders, and these builders will be sometimes the robotic construction methodology, sometimes again like human beings. And here we will be able to use all these type of very smart construction methodologies for this project on site. And for all these things, like parametric architecture is a key tool, but it's above it, I believe that it's all related to building information modeling. And all these things are united together through technology, and this type of museums will become kind of a monitoring and research center. And again, as James was saying, this is not only during the design and the architecture part, also the living part will be like the social life inside these buildings will be able to all connected to each other through social commons. And also there will be in service, all these robotic services will be active for this project. So in general, I have to also say that soon in the near future, all these developments in between architecture and technology will enable us kind of to become system builders for architecture. So not only the tools are getting smarter, we are getting smarter and we get connected together. Thank you very much.
Wonderful, wonderful, Melike. My goodness, compliments to you. What, wonderful, magnificent, large. I mean, I will run out of the words. Am I audible? Can everybody hear me? Awesome. Now, Melike, that was tremendous. I mean, needless to that, for a moment, I felt speechless in the sense to look at your projects and the kind of magnitude and the thinking that would have gone to do these. Let me bring Sushant, very quickly and hear from our friends from India as to what is the leap that we have taken forward in parametric architecture. But let me tell you on Sushant, he's been really imparting great education, not only in India, world over. Over to you, Sushant.
Yeah, so I'll just try to go through various kind of projects that we are doing. For me, computational design, which is a term which I more commonly use than parametric design. Parametric is a more popular word, more commonly used and understood by a lot of people. But in essence, it's actually computational design where we are using computation and we are computing a lot of information and data. Data being a word which we heard in the previous presentations as well, because most of us are actually doing nothing but manipulating data and using data to kind of create better spaces and solve much more complex problems as well. So talking about the works, of course, we've been working on various scales of works. We work very collaboratively with a lot of other designers and studios and independently as well. So I'm just going to brush through very quickly while I talk about the scalability aspects of the works and how we actually use computational design. What you see on the screen is kind of a smaller scale, getting into slightly larger scale, more of installation and purposeful use, where we have used computational design to rationalize the form and optimize the fabrication aspects of the project. These are some experience centers and exhibition spaces which are dismantleable and can be assembled again into new spaces. These are a few glimpses of some installations. What I also want to throw some light on is the technical aspect which goes behind these forms, because as James also rightly pointed out, it is not only about the form or the geometries. That's obviously one major part of it, but more than that, there's a lot of data and information that we are working with. This, for example, is a prototype of a facade. And on the right-hand side, what you see is the radiation analysis of that facade with the specific numbers and the data information embedded into the model. Over here, you would see the structural studies, the CFD analysis, which we typically carry out for some of the installations and projects. Going slightly on a larger scale, this is an interior space, an experience center where the lights that you see over here is actually CNC cut marble, white marble, which we typically use for flooring. So of course, we try to bring in innovation in various aspects. In this particular aspect, the program kind of was seeking innovation in terms of materiality and lighting, which we kind of made possible using computational design. And of course, then we use the recursive approach to design the mathematical fractals, which forms the entire shell of this inner skin. The same thing goes on to variety of projects and typologies as well. These are a few restaurants which we've done. This is a lighting installation, a project we worked with a lighting designer. This was a collaboration with a fashion designer. I'm trying to show you a variety of scales and typologies which allows us to kind of work within the realm of computational design. These are like some office spaces and experience centers which are built across different cities in India, which have certain features of parametric design. At a smaller scale, at a product scale, we've also designed like trophies and awards, which also have a parametric approach to it. This is a shopping center in Tokyo, which was a collaboration with the Japanese architects, which was more of a form finding approach where we use physics engine and simulated the environmental aspects of the same to optimize a skin, which is like a large scale complex or a small scale city, I would say. Just a little video to show the kind of simulation that was done, which is a fairly simple one. Typically, we kind of teach that to our students where you have to do kind of form finding and how the structure is kind of resolved of the same as well. This is like some aerial views of the same from the outside and the inside. And all of these panels are actually adapting to the climatic aspect of Tokyo, which we used to analyze and define the sizing of each and every element. So parametrically, of course, it allows you to create a multitude of geometries, but you need to be able to control the information and data. Here we're using the environmental aspect to rationalize the form, which again, you can see here. This is a facade project, which was more of a high tech and low tech. This is another facade in Hyderabad, which we 3D printed at a small scale to make sure that a facade engineer in India who is not adept with the high tech technologies is able to understand. So we have to simplify the complexity of any geometry and rationalize that based on any project. These are a few more facade projects, ongoings, few canopy structures, which we again prototype at smaller scales to understand the fabrication. So it's a back and forth process. It's not that we are only working with computers to give us a form or a data or information. This is one of the upcoming projects in South India. It's a temple project where we've used certain principles of Vastu and numerology to inculcate that into some sacred geometries and forms, where we used an 11-sided hendecagon and created a variety of forms. We basically started with an algorithm which creates a multitude of forms, analyzed and evaluated environmental aspects and structural aspects of it to end up into a particular complex geometric formation. This is a tower in Hong Kong, which was also a competition. An upcoming project in Australia, which we're working on. It's a cricket stadium. We're quite excited for this one, where it's more of a very simple form, but the whole idea was that we actually started with developing a tool to design a stadium. So we not only work on the actual architecture or the design, but on the idea of tools as well. So this one actually started and initiated with a tool development that we were doing for a sports infrastructural company, which ended up into this project where we are using the tool to evaluate the C value, the horizontal angles, the vertical angles, and optimize a seating layout, and kind of creating a design through through an algorithmic process using that. So there are a few more snippets of the stadium. And yeah, so I mean, for us, computational design is basically something that, a tool which actually allows us to work on a variety of scales and typologies. And that's pretty much, what our articulation of the tool as well is. These are a few interior spaces, a project in Mumbai. This is a technological campus, again, on ongoing project in New Delhi, where we have this weaving kind of a structure. It's like a triple layered skin, which has this understanding of, protecting you from the harsh sun, providing a nice microclimate inside, and is able to kind of rationalize the geometry so it can be built and fabricated at a low cost, low tech technologies that are available for the construction in Delhi. So these are a few more facades, which again, it might look very complex now, but the moment we rationalize that, there are actually only 4 kind of modules which we are making in a factory, and are able to play around with these modules to be able to create some parametric facades. Uh, this is another religious project. It was a competition in Dubai, which is of a mosque where you have these columns which actually start to appear as arches when you see them in perspectives, which was pretty much the whole concept which we articulated through some complex jalis and roof structures and formations. So that's pretty much what our journey of computational design has been, in terms of going from something as small as a product or a trophy to a fabric or a dress to an office space to a large stadium. So that's pretty much, we believe that computational design really empowers architects, especially in today's age and date, where we have the access and means to learn technologies. Yeah.
Awesome. I mean, what do I say? I mean, right from extreme, from a small things like a trophy to such a large project, especially the one that you're doing in Australia. Tell me, Sushant, what are the kind of learning curve that you see on the client side, because it's so technology, and especially in the religious places, you need to marry the Vastu and the numerology. So how really on ground that you feel it is it really challenging, or is it so easy? What are the hiccups that you face?
Right. I think it's very challenging because there is very less awareness about the subject. So that is the most challenging aspect, and not just within, not just outside the fraternity, but within the fraternity as well. Most of the times we are actually collaborating with other designers. So there is obviously a challenge because there are a lot of expectations from technology. People actually expect technology to solve your problems and give you a solution. On the flip side, technology does none of these things. That's all that humans have to do themselves. So we actually have to become smarter and adapt to the new technologies, and to be able to use them smartly. So the main hiccup that we often feel and try to overcome is, how do we merge the understanding of people, like Vastu principles, for example, have a lot of constraints. So typically we would work around in blending and marrying high tech and low tech together, not just in terms of technologies, but also in terms of the thought process, because that's where the contextualization of how you're using these technology matters a lot. Whether you're designing a building in Australia or you're designing a building in South India or North India, all of these are extremely different contexts and require a sense of solutions to the complex problems that are existing. But I think the times are changing. People are becoming more aware. People are becoming smarter and are able to understand technologies quite extensively. And there are a lot of people now who are able to use these technologies as well, which is a good thing now.
I think that's a great sign, especially we were very keen because we were a lot of people from India watching and listening to the show, and in terms of the adaptability and scalability. And definitely the way you summed it up, I think there's a bright future and of course a lot of scalability, but we will labor on that in a second part of it. But let me get Amit very quickly in, because he's one of the finest young professional designer from our country, and he's done a lot of work, especially in the field of parametric architecture. Amit, we would definitely like to know, how is this giving you a cutting edge in your practice?
Thank you, Bibhor. So I'll just share some slides with you. So I think coming to parametric architecture or computational design, for us, it's a tool. Architectural tools have changed from back when using hand-drawn architecture to more physical models. Now it's digital tools. So for us, it's very important that the parametric tools have a meaning to the architecture. So it's all about performance-driven architecture, what you're trying to do with this tool. So for the purpose of this talk, I've split this into 4 different topics. So speaking about performative aesthetics, usually there is a mindset that, something which is sustainable is not beautiful. But it's not true, something which we work with very nicely, you can marry the two. You can make sustainable architecture also very beautiful. So the first project is a high-rise tower we are doing in Bombay, in Warsaw. So here the design tree which we're looking at is a view. So as simple as coming as a view and cutting the solar heat gain of the rest of the building. So we are very fortunate to have this site with this marvelous views of the waterfront. So here the tricky thing for us was to marry the client brief also, because the construction cost, construction time frame, delivery time frame had to be looked into. And for us, design tree which we set was that every apartment, every room has a view to the waterfront. So through some iterative design, we did a lot of optimization studies to see how the apartments are changing in terms of verticality, and also that the tower in front is not shadowing the tower in the back. And looking at the image on the left, what you see is pure glass, because this is the face of the facade which is looking towards the waterfront. And on the side is solid actually. So it goes from glass to solid on the side. So in a way, we're just trying to capture the views towards the waterfront. And the core is sitting on the back of the building. And then once you're in the apartment, you get this uninterrupted view. So the thing is, to set up a very difficult design tree with two towers shadowing each other, we are still able to make sure that every apartment, every room gets a view of the waterfront. So doing a lot of iterations and running through strips to get an optimized design. So this is from the waterfront looking back to show that there's no shadowing effect which is happening between the two towers. Second part of this is data-driven design. So architecture defined for us is a combination of art and science. So I think computational actually helps us merge these two things together, because we can use mathematics and computational techniques and create something which is a bit more artwork. So this project is a perfume park and museum in Kannauj, which is also under construction. So for us, the thing which we looked at was the Fibonacci series, which is inherent to the base grid of a flower. Given that the project was a perfume park and flower is where the perfume is made from. So for us, it was very important to take something which is not very literal, but to create a natural system and then deploy it on the site. Again, through these parametric or computational tools and techniques, we made the base grid. And then this was really a data-driven piece of architecture, because it was all ruled by mathematics, which comes from nature. So this was the overall planning. And we have the central museum building which is sitting there, which is also an interpretation of the three petals of a flower. And then the same system of Fibonacci is also projected on the ceiling. So it's also parametric architecture gives us the possibility of creating unified architecture, where everything can come together as one system and all the other subsystems integrate to this. The third one is a railway station. We're doing Gwalior railway station. So this will also go in the construction soon. So here the theme for us was to create something which is large span, because it's an existing station. So we cannot really come up with a new grid. So the largest span we have is 32 meters. And then our design iteration or ideation actually started from the existing station building, which we see on the left. From this, we took the arches, transformed them into a 3D module, which became the overall formal expression of the building. So in a way, the new actually resonates the old. So parametric is not necessarily destroying the old, but it can be also used to highlight what is already there as per history of our country. And then the beauty about this for us was that architecture, form, function, structure, everything is a marry of one simple component. So it's a modular system which can be repeated, and it is transformed and translated in one or two places for changing in the spacing because of the spanning of existing platforms. And then again, solar simulations were done because stations are very deep flow plates. So we want to get a lot of natural lighting in there also. So based on this, we gave a lot of this punch windows, jalis on the roof to get this nice shadow patterns on the floor. And also the shadow patterns will animate throughout the day. And this also becomes a visual interest to us. Then prototyping is one of the most critical aspects. So this is a built image of a prototype for which we call Smart Lounger, which was done by us. So sustainability was at the core of this. Doing curve form, we actually end up losing a lot of material. But curving is whereby just cutting the wood, you can bend the wood. So the analysis for us was trying to understand how much is the stress analysis on the form. And what you see in the bottom of the screen is the only piece of drawing which was given for execution to the carpenter. So in India, we have to also look at high tech and low tech. So we do a lot of stuff in the back end, which is high tech, which is computation. But the execution drawings are very easy to read. So this is something which we are trying. Before if time permits, I have this very short animation which actually covers this 4 topics.
Yeah, please go ahead. Please go ahead.
The second part is data-driven architecture, where again using computational tools, we were able to reduce the heat gain of the building, Hilton Kathmandu. This was very interesting because the building FSI kept changing constantly. And this is the execute project, which is Hilton Ahmedabad. So we create a parametric model whereby you can constantly keep on changing the form. Again, you can do a lot of, blending systems using the systems hereby, which is the Allahabad master plan. So we went from row housing to group housing to towers. Then as a part of sustainability, this is the other station which we are doing, which is Bangalore train station, which was a resonance of Bangalore, which is a smart city. So here we did a lot of flow analysis for the station building. So these are all projects which are under construction or going to go under construction soon. So using these tools and techniques, we can actually check the surface area, because in a station, we need to maximize the surface area of the front of the building to ensure multiple in and out from the building. And yeah, so again, this is same what I showed you earlier, the Gwalior station. And last is the prototyping bit. So actually, it's very important that digital and physical speak to each other. It's a feedback loop which you have to create. So you cannot just have digital without the physical. So prototyping becomes a very important part of this architecture of parametric or computational techniques. So yes, Vibhor, that's it from us. Thank you very much.
No, Amit,
any questions?
No, Amit, thanks. I think looking at the kind of scope of work in terms of, now I'll also start saying computational design, no longer that in terms of parametric architecture. I think this is a fabulous work, Amit, that you are doing in the country. And I think you've really covered the entire country that one can see. And the work has gone across from commercial to large residential. The entire bit that we see here.
There are a lot of people asking a common question, if I can put forward that question to the panelists.
Yeah.
They want to know, is parametric architecture design, like what's the future of parametric architecture design in India, and how can it be scaled up?
Okay, now that's a very interesting question, and I think two gentlemen are from India. And we're very keen to take this question. We will, put it together for Sushant and Amit to answer that. Amit just went through the presentations. I'll ask Sushant to, answer this audience question.
Before, sorry, my system crashed. I had to reload.
No, it's all right. It's perfectly fine, Amit. Actually, there was some very nice line you said, and I think, again, it's all technology I could barely hear, and that's why I wanted to hear it again. But nonetheless, on the other side, Sushant, Amit, if you could have heard the question, which is like unanimously coming from the audience, is the scope of PA. I love the word PA. There's a new terminology which has just evolved. PA is scope in India. So, and I've just asked Sushant to share his thoughts, and then I'll come back to you.
So I'll tell you what's happening in India. The problem is, I'm sorry, I'm taking from a very pessimistic point of view. I'm going to start from that because I was too optimistic in my presentation, I realized. So the problem is, for the last 10 years, we have actually been questioning that what is the future of parametric design in India.
Sushant, you can be brutally honest. So sorry. Honest. Yeah.
That's what I'm trying to do.
And that's why viewers, we are not doing pre-recorded, we are live. Yeah. All right. Go ahead.
So, of course. So the problem is, for the last decade or so, we have been questioning that what is the future of technologies or parametric design in India. And that is one reason why in India, we specifically try to remain on the other side of technology, where instead of actually adapting to it, we are always questioning a technology. And that's pretty much has become our mindset. And I don't blame people for putting across a question like that, but it's been a common question. I used to ask the same question when I was not adapted well to use technology, I would say. And with time, you start to realize that what are the potentials of that, and what are the challenges as well, and what are the pros and cons, both sides. So I would say the future, there is no future. Future is already gone. That's in the past. We have been using technologies in India for the last, 15, 20 years as well. It's just that how much we are using it is something that needs to be looked into. So I really don't feel that there is no future, because you can get as specific as possible as that. Do architectural firms are using technologies? Yes, most of them are. The ones who are not, they really want to. I can tell you that from a very personal experience of working with architects. Everybody wants to use technology because it actually empowers you to do a lot more than what you're able to do otherwise conventionally. That's my take of the future of technology. Probably Amit has.
Yeah, so I think people, you heard the very candid one from Sushant. The technology has been there, and people wake up, embrace it, acknowledge it, adapt it. Sooner the better. Don't distance yourselves. But let's hear from my panelist, Amit. Amit, the question was, what is the future of PA in India?
PA, as you mean, parametric architecture.
You know, I learned this one. Thank you people for giving us this one. You know,
Not just PA.
yeah. All right.
I think parametric architecture is just a next evolution in design. You know, it's not something new. It has been gradually happening over time. And over the last 20, 30 years, actually, Eisenman and all these guys were anyway doing this. Now we have the computational power also to use this. And some softwares have been made a bit easier to understand for students or architects or faster to learn. So I think in terms of future, it's, you know, it will become a part of mainstream architecture soon because of, but you know, there's one misconception that parametric architecture makes you do things faster. It's the other way around. Because if you're doing something with parametric, you have to take more time to set up the constraints and rules and guidelines. So it's a time-taking process. After it's set up, then you can automate it. But so this is a misconception usually with time, that if you're doing this, you know, if I have a 20-floor tower with 2 acres, Amit can change it to 50 acres and 10 floors in one day. It's not possible. So, but it's all about automation.
That's interesting. I have a follow-up question to this, and this is directed to Melike. People want to know, like, what's the role of AI in parametric architecture?
The role of artificial intelligence in parametric architecture. Actually, it has been started happening like step by step in the past years, but actually it's a growing thing. But I need to connect this question actually with the previous one, because all the audience, they have to know that parametric architecture is not a magic tool. Actually, the parametric architecture is already hidden in the architecture itself, in the space making itself. It is currently using just digital tools instead of the mechanic, like instead of pen, we have been starting using computers. And as Amit was saying, this helped us to really use our time differently, because it gives us the opportunity to see, instead of 2 or 3 options with your hand drawings, you may be able to only create this kind of options for your design proposals. In this case, we are able to create really millions, thousands of options. And because the data is same, because you are the designer, you are the architect, not the computer, not all these tools. They are not magic tools. But when artificial intelligence comes into the play, then it will also go a bit beyond because we are. That's why I was saying that as architects, the ones that sitting now around this webinar platform, we are using these tools very advanced, in an advanced way. And we are not afraid of using them, because at the end of the day, you are the rule maker. You are the one who sets the constraints. You are the one who chooses between the millions of constraints, certain ones. Because according to your design philosophy or like many other reasons can be your filtering palettes for your architecture proposal. But when AI comes, it will help us in a different way, because it will take the data from really different sources. But again, in that sense, again, we will be in the same position, I believe, because we will be so confident about using this tool. Not only, that's why today I wanted to show you examples, not only related to the design part, also the construction part. Maybe in India, the communication between this computational design and the construction is not linked very well, and that's why people maybe they don't embrace this thing quickly, because if you only design in the computer, it remains in the computer. They need to see it happening, they need to touch it, they need to be inside that space, and that only happens if the digital fabrication techniques also develop for architecture and for construction more in our countries. That's also a very important thing, because we design to really create these spaces in real, to build them. And AI is getting faster and faster, and it will. And it will accelerate. I mean, we have been dealing with this subject with Amit since 2004. It has been already 16 years. And actually, I have to say, nothing changed so much since 16 years. I have to admit that. Like we have been, I mean, okay, some tools got smarter, okay, but since AI is starting to get into it, then we will see a really totally different way. But still, no one needs to be afraid, in my opinion, because we will be the designer, the system designers of those things. Yeah, that's my point.
Wow, wow, wow. Sorry, indeed, I couldn't hold my excitement, because I think that's the great messaging, Melike, what you can. I mean, irrespective, no matter how much we are bombarded with technology, but I think our designers are much sharper. And they're going to tame this technology and play it to the tune that they want, which will help them to harness the full potential of a project. Is that the right way to put it, Melike? I think that's
exactly. Yes.
So hats off to our designers. Absolutely brilliant. And Esra, I mean, we can't leave you being so quiet, And, I just wanted to see, I mean, your reactions. We heard so much from great panel. And of course, there are more questions in the audience, but let's hear from, a few words from Esra. What would you like to take your take on? I know, not on the subject, but what you feel after listening to our, lovely panel.
Yeah, it was a very inspirational webinar, because parametric architecture is a very deep world. So I'm so glad to be together with these panelists. Actually, I took so much for myself and for my company. There were some questions in Q&A. I tried to answer most of them immediately. They were asking how glass will take place in parametric architecture. The audience might think that glass is a rigid material. Yes, it is rigid, it's okay. But on the other hand, it's extremely flexible. And with the technology, with the R&D studies, glass is ready for parametric architecture. So thank you very much for this wonderful webinar.
No, absolutely, Esra, and people out there, I think when we were talking about topics and our own research team said, there is so much is happening, but nothing has happened on this subject to a level where we can bring together the best minds together. So thank you, Esra, for, helping us co-create this one. And, Indrajit is telling me on the other side, there are more questions from the audience, and we love our audience. Thank you, audience. So it's all their flow, their time. Please ask questions from there on their behalf. Indrajit.
Yeah, there is one very interesting one, and they want to know, Pooja Todi. Pooja Todi wants to know, how can parametric design help and contribute to sustainable development? So anyone can take this, any of the panelists?
I think Amit mentioned about this, but let me take Melike on this one, and then I can probably come to Sushant. Amit, you really covered in your 4 very important points, sustainability, and I think for that person who's asked the question, let's hear from Melike's point on sustainability.
Actually, in that sense, especially related to sustainability subject, I think the materials will become very important. So we can use the parametric architecture to use different types of materials, to combine them or create like hybrid materials, and to create all these components, architectural components, to create these spaces, the structures of these spaces, or the wall. I mean, depends on the designer again, but I believe that the sustainability, especially related to ecological subjects, in my opinion, the type of materials becomes very important, because it will help us to really combine them, or use also really, instead of using only steel and concrete in a very ordinary way, we are able to, through these computational design tools, we are able to really implement other type of things. Yeah.
Okay, Sushant, your take, and then I will take the master in terms of Amit himself on sustainability. Yeah.
Yeah. So just to add to that, yeah, I mean, okay, one thing that happens when we are designing computationally, you know, we are kind of seduced to creating some kind of complexity and some kind of complex forms. That's something that kind of bounds to happen. There are a variety of reasons for that as well. But when you do that, when you're creating some kind of complexity, you are kind of questioned to justify that complexity as well. So I really feel that a lot of times you're actually trying to optimize your designs, optimize your geometries to the environmental aspects much more consciously than what you would do otherwise conventionally as well. So we have the tools right now to be able to understand climatic information and data, and we can articulate that and kind of remap that data into some kind of geometric information, be it facade design or be it designing a roof structure. These are variety of aspects that typically we take into account and factor into account. So we are actually designing and leading towards more sustainable futures, I would say as well. At the same time, in our practice, we have developed some in-house tools as well, using the open source tools, which can help us understand the rating systems as well. So when we are designing, we can actually check if we are able to understand and evaluate against a parameter from the LEED rating system or a GRIHAR rating system or any other green building rating system that exists, depending on the kind of project, be it the kind of glass that we are using. Of course, materiality becomes the next level as well, aspect of putting in more sustainability. But I really feel that using computational design, we have access to so much of data of our geometries that we are able to optimize that with a variety of climatic conditions.
Wonderful, wonderful. Absolutely can't agree more. Amit, you would like to add on to this as well?
I think sustainability really comes into play because of simulation studies. Before parametric, simulation was not possible. There were these handbooks for sustainable design where we have made this matchboxes and done some it was thumb rule based. But now for the exact location, exact site, we can do wind analysis, solar analysis, heat gain studies, a lot of these things. So simulation is the main thing. And like you were discussing, Melike, and Melike was also pointing out, so AI is something, which will always, it's all also artificial intelligence in a way, what we're doing. When we start running a simulation and we are getting a feedback from the system itself, it's actually using the system smartly, not just to create cool architecture, but to create something which is a bit more meaningful. So, yeah.
Wonderful. And I'm getting the message from the team that we have more questions. Indiji, you would like to take an audience question, another one?
I'll just take one more. I'll club two questions in one probably, and then we can conclude. This is from an anonymous person, but the question is interesting. Parametric design involves a lot of customization of material. How do you cope up with the waste generated? And which material is best in terms of quality and cost for parametric wall?
Can you just give one more time the question?
Sure, I'll repeat it. Parametric design involves a lot of customization of materials. How do you cope up with the waste generated? And which material is best in terms of quality and cost for parametric wall?
Awesome. Very brilliant, two anonymous people, and more brilliant is Indijit to marrying the two questions together. So he's put a very nice one together. Who would take it? And anybody, I mean, like Melike, Amit, Sushant. Maybe
any material is the best material, in my opinion.
So say that again, please.
Any material is the best material because it depends which one you choose and how you really deal with the problems related to that if he's asking to create a wall, whatever the design problem is and whatever material you choose according to that, like I wouldn't say that this material is the best, because I will ask which digital fabrication methodology you are using to create it, because even like for the same material, for the same design, you can use different types of manufacturing methodologies. So it depends on the really from design to production, which methodologies from the zero, from the end you choose. So my vote is for all the materials. I cannot say.
Melike people is very, very flexible and very, very adaptable. You give any material, you see the magic. So let me just, so she says any material. Coming extreme on my right on my screen, Sushant. The waste fact, the wastage part.
Yeah, also I would like to add to, because on the wastage part and customization. So, so back in the 1960s, or during the time when Industrial Revolution happened, everything started to be produced in factories and industries. And that's when modularization actually happened. And that's before that, everything was custom made. And suddenly everything shifted into becoming modular and becoming repetitive. And that's pretty much how architecture also started to adapt to that. Right now, we are in a time where we have the possibilities of going bespoke, and we have the possibility of going customize anything or even personalize something. And that's pretty much what is kind of is the need of the hour. And we have the technologies to do that. So as I mentioned previously as well, we can compute data, we can compute even the costing and the wastage as well. All of that can be done if you're consciously using your data and the geometries in the right way and smartly. I would also kind of question to someone who asks this question as well, to ask themselves that when you don't use computational design, when you're designing normally, how much you actually think of the waste materials, and how much actually are you computing that waste material is used. That's something that we hardly think of as architects and designers. We just choose a material. But the moment we have something which is more complex or customized, we start to question that, okay, it's going to lead to wastage. That question arises, but that can be solved as well if you're using the data consciously. Depending on the kind of projects, we do use variety of optimization approaches to minimize the wastage, maximize the potentials of a particular material or a product.
Yeah, so that's it. I think Sushant said and Melike said, any material, he said how to use and manage the waste. Amit, your closing statement on this, and then we can do a final one, a quick fire, and then end of this session. Yeah.
So first of all, I think if there's too much wastage in design, I don't know how much wastage the person who's asking the question is getting, then the easiest thing is your design is flawed. You need to change the design. Because let's say in Hilton, Kathmandu, usually a glass wastage in a building is considered as 18%. 15 to 18% is what we consider a typical glass wastage from a sheet side. In Hilton, Kathmandu, through optimization, we reduce the wastage to 2.5%. So, it's all about how you use the tool. So, I think also depends on design. So, I know where this parametric wall, when this person said it means this ribbed wall, where you have this undulating wall. So there, if you're using a CNC with cardboard, there might be a lot of wastage there. But then even there, if you do nesting of components nicely, like Sushant showed one project in the beginning, I think it's all about, rigorously working through the system, trying to control it.
All right. So I think it's almost 1.5 or, already there's another one popping up. Very nice question, though. I love them. Please keep sending. We will ensure that these questions would be sent to the panel and they can, answer that as well. But, one thing which really intrigued me, and one of the gentlemen in the audience said that why don't we include PA in the curriculum so that the breed that is going to come out, the students are going to come out and embrace this world of design and architecture, they would have a quick, lead and a quick start as well. Well, before I conclude, I think I'm just going to quickly come for 30 seconds to each one of you. Melike, your message to the young minds and people, especially how to use PA or parametric architecture or computational design so that you can harness the best. Your 30 seconds from each one of you. What is your message, especially on this technology, this methodology to the young minds, to the young upcoming designers?
I mean, I would like to tell them that if they want to really discover the unseen logics behind what they are doing on white paper with one pen, they would really try to get closer to these computational design tools to discover more, to generate more for future of our environment. Yeah, that's
very nice. Wow, I love this small 30-second, and you really kept on the brief. Esra, your 30 seconds that you want to say anything. Not necessarily PA, but I know.
Okay. For young minds, I will ask them not to hesitate to ask any question, anything about architecture or glass to either us or the panelists. Thank you for this inspirational session.
Yeah. All right. Sushant?
Yeah, I would say, we have spent a lot of time. We spent the last 1 decade or so questioning technology. So I think it's high time now that we start to use technology to be able to understand it more and understand its potentials and challenges both. There are both sides of it. I would request most of the more architects to actually enter into the domain of design technologies to be able to develop it forward, and it has actually been developed in an open source environment, all the computational tools. So that's how the learning needs to happen. So just join the journey and embrace it.
Wow. Join the journey, embrace it. And now I come to Amit Gupta. Your final 30 seconds. I mean, I will give you the last one. So you please take the little luxury of time in case you want to overshoot that time.
Actually, I would keep it very short. So I read a very nice quote somewhere, which is learn the rules like a pro and break them like an artist. So I think you need to learn the software properly and practice architecture rigorously before you start, creating this masterpiece.
Wow. I'm absolutely floored with my panelists. How much I love you guys. I mean, you really mean, if I tell you 30 seconds, you'll do it, 5 seconds earlier. But ladies and gentlemen, and the viewers out there, it's a big thanks to all of you for being there. And I can continually see your love by raising hands, asking questions, and your numbers keep encouraging us. Never went down. So very good, very encouraging. Thank you very much. But one of the most important thing, when we approached the subject, we were very apprehensive in terms of the kind of, as Sushant, Amit, and everybody in the panel said, don't get scared with technology. And I tell you, as an individual, I am actually at times get dwarfed with technology. But let me let you know, during this lockdown, I have really come up out of this fear, and I feel that I've arrived. I really have lots of confidence in terms of technology. And who better than the designers? They have used technology to the hilt, and you've seen the success that they have embraced and the journey they have embarked upon. And the message to all the young minds: please take technology seriously. Melike had put it in a very nice, small way. Embrace it, adapt it. You will be the winner. So, ladies and gentlemen, parametric architecture, PA, is the new word that we learned today, computational design. It was a very enriching and a learning experience for me, being with the panel here. And I still see a lot of questions coming. We really love your questions. And my team and I will make sure that the question reaches out to this eminent panel, and they would take time out to really educate. And because of your being continuously with us, it gives me a sense and a motivation and a drive that we must take this session forward in some form or the other, Esra, with your permission, to make sure that the continuity remains, because this is such a subject which needs more deep diving. Sushant, you've been doing lots of education. Amit, you have done excellent work. Melike and my friend James Law, thanks a ton for all of you for your time and for imparting such great knowledge, great sharing. And we from ITP and Sisecam wish everybody all the very best and more successes and more milestones. Thank you from all of us here.
Thank you all.
Thank you.